right, hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. For the following sequences, plot the first 25 terms, that's a lot of terms, of the sequence and state whether the graphical evidence suggests that the sequence converges or diverges. So for this one, I'm not going to do a whole lot because on number 44, I kind of showed you like what we would do for that one. And so this one's going to be almost exactly like that. And the answer to this one is available. Like if you just click on the number 45, it's like a linked number 45. So you just click on it and then it takes you to the answers. And then you just wait a second for it to like scroll down automatically and it takes you right to what the answer is supposed to be. So actually this one already has probably has all those numbers in it. Actually, you know what? Let me find out if it does. I'm going to do that right now because I have the answers pulled up. It looks like, so they did graph it, but they didn't like, it looks kind of weird. Like you can tell that it's jagged because they're going for like specific values of like n equals 1, n equals 2, n equals 3. But they didn't actually tell you what those specific values were. They just graphed it, and then you can tell it's like a jagged sine wave, basically. I mean, it's a cosine, but like, you know what I mean. So actually, they don't have the actual numbers in there. So let me know in the comments below if you want to see what those numbers would look like, so you can graph yours. And I suggested that you can do that for the previous one as well. So if you're also having to do number 44 and you skip the 45 for some reason, I don't know why you would do 45 before 44. That's just weird. But you know, hey, no judgment. So if you need to see some of those values, like what is the cosine of 1? What is the cosine of 2? What is the cosine of 3? I'm probably going to round them to either 2, maybe 3 decimal places. Most math professors want 2. That's like the standard. It's like the unspoken rule of mathematics is just to round everything to 2 decimal places. But if you wanted to look at what the graph would look like, you would do something like this, and maybe like, I don't know. The last time I did this, I had it where every other space was 1. I'm actually not going to do that, I don't think. I think I'm going to have it go like, well, maybe I will. Yeah, let's just do that again, because why not? So we know that the cosine graph would start up here, but you don't start at 0 for a sequence, right? The default starting place is 1 unless otherwise stated. So we would have the cosine of 1, then the cosine of 2, then the cosine of 3, then the cosine of 4. Now the actual graph would be that cosine of between 1 and 2 would be about cosine of pi halves, right? Because pi is about 3, 3 halves is about 1.5. So somewhere in the 1.5 range, you'd have the cosine of pi halves. And that would be about 0. So that would be like about right there somewhere. And then the cosine of roughly 3 would be about at the bottom. Because remember, the cosine of 3 would be roughly the cosine of pi. And the cosine of pi is negative 1. So 1, 2, 3. So that'd be about right here. So the graph would look something like this. Right? But it's a wave. So it's just going to keep going and going and going, like the Energizer Buddy. And you just plug in those values for cosine of 1, cosine of 2, cosine of 3, and you do have to be in radian mode. If the teacher wants you to be in degree mode, I guess do that instead, but typically you always default to radian mode if they don't say what mode you're in. So we're default radian mode, we're default starting at 1 for a sequence. Those are the natural defaults. And you just type in all the numbers, right? So like what's the cosine of 1, what's the cosine of 2? And then you would just do that for the first 25 terms. And then you would say, oh, hey, look, it looks like it's not converging onto anything. It's just waving. Imagine that. So then you would say that the graphical evidence suggests that the sequence diverges. You would say it diverges because the limit, when we say if the sequence converges or diverges, we're saying is the limit some sort of constant. So the limit as n goes to infinity of the cosine of, not the con, the cosine of n is d and e, because the cosine is not the limit as n goes to infinity of the cosine of n, because that is not a constant, it diverges. It could be either infinity, negative infinity, does not exist, something like that, indeterminate, whatever. Anything like that where it's not a number, basically, then it would diverge. If it's a number, if it has an answer, then it converges. If it doesn't have an answer, then it diverges. That's like the simplest way I can think of to say it. So that's pretty much it. So again, if you want to see what some of those numbers are, all 25, sure, why not? Just let me know in the comments below, and I can work out those numbers for you. But yeah, other than that, I will catch y'all in the next video. Oh, don't forget to check out my 5 math mistakes everyone makes and how to avoid them. Link in the description below, myirishmathematics.com. Blessings, y'all.